Hello everyone and welcome to the second launch attempt of Firefly's Alpha rocket with message in a booster. I want to welcome everyone to the live coverage here of the launch, as we are just about 25 minutes or so away from the launch, so we still got a bit of time until the launch. 25 minutes and 10 seconds. The second launch attempt for this rocket, so very interesting. And yeah, basically that. So we got about less than 25 minutes now. And beautiful shots of the rocket here. So about today's payload, if you haven't seen the live stream yesterday, let me just take you through the Alpha rocket itself. Height 29 meters, and the fairing is 5 meters in height, 2 meters diameter, and the rocket is actually 1.8 meters in diameter. So very interesting. It can carry up to 1,000 kilograms into orbit, LEO, and it has 2 stages. So a simple, small, big, small launcher, small sat launcher. So today we'll be launching the Lockheed Martin 400 demo, and these are going to be the first of up to 25 launches of low Earth orbit technology demonstration satellites to be built and operated by Lockheed Martin. So this is a demonstration mission for Lockheed Martin's 400 satellite bus, or Lockheed Martin LM400 satellite bus, as they call it here, which will carry a communications payload. The satellite bus is customizable to support different missions, including remote sensing, communications, imagery, and radar, as well as orbits and launch configurations. Which is pretty interesting. So it's one big payload, as big as a fridge, is what they said earlier. So this is going to be the first, if it launches, the first, I hope I don't jinx it again, it's going to be the first mission of 2025 and the 6th mission of Alpha overall. It has an okay success rate. Well, they have more failures than successes at this point. So if we take a look here at the previous missions, the first mission of Alpha was in 2021, which was a complete failure, as many know. It completely exploded after T+1 minute, and a partial failure in 2022, where it was able to achieve orbit for the first time, but the payloads on board were deployed in a lower orbit than expected. And then the third launch, which was Victus Nox, was successfully launched, and that was a complete success. And then another problem, launch partial failure, with Flight Lightning in 2023, as the Stage 2 second burn suffered problems and did not deliver the payload to its precise target orbit. And I think Corey told me yesterday that the satellites eventually deorbited, so not sure why that is stated as a partial failure. It could be the other launch. And then the latest success on July 4, 2024, which was the only mission in 2024. So let's actually listen in to the countdown at.
Readiness report for terminal count will be in 1 minute. All right.
There you go. 1 minute.
Count.
You
I
have
got
1 minute
to explain it. But yeah, so each of the people that you see in mission
Let's
control
receive the
are
broadcast
looking at the
itself.
health of their
spacecraft has
systems.
transitioned to internal power and is configured for launch.
All right.
Really trying not to talk over.
Yeah, we really don't want to talk over them there.
Yeah, so Justin Fullen, our LC, will ask for a go or no-go from each of these guys in the room.
Right.
And they're making sure that their systems are healthy, and so over 20-plus subsystem alpha leads, payload lead, range operations lead. It's not just Firefly, it's also the range.
CD1.
Right.
And
And the customer.
And the customer.
LCC gate has been met.
Here we go.
Nice.
Acknowledged. This is the launch conductor on the countdown net with a ready report for terminal count. RC, go. FSW,
Go.
GSW, go. GNC, go. Prop 1,
Go.
Fluids 1,
Go.
Structures, go. TI, go. FTS,
Go.
GC,
Go.
VC,
Go.
PMM,
Go.
LO,
Go.
FISPO,
Go.
MIFCO,
Go.
OSM, ROC,
Go.
MA,
Go.
CE,
Go.
LD,
LD is go.
LDA.
LDA, clear to launch.
We are go for Flight 6.
Wow. Good news.
There you go, folks. That was just right down the line. Quick, fast, and in a hurry. Every station reporting in nice and clearly that we are go for launch.
Might have given a fist pump back here. No one will see it. It's okay.
Luckily, our cams were off. We were over here cheering as all the green lights turned on. So coming up on T-minus 19 minutes, that is exactly what you want to hear during the poll. All of the lights going green. Now things are going to start happening pretty quickly. So let's talk a little bit about let's talk more about the parts of Alpha. Unfortunately, can't see them on the screen right now, but I think we have some movie magic to share with you. What makes an Alpha?
Yeah, so Alpha is a two-stage Kerolox rocket. And what that is it's RP1, which is basically just kerosene, and liquid oxygen, which is a cryogenic fuel.
Right.
So this rocket can take about 1,000 kilograms to LEO, which is low Earth orbit, and it is the largest vehicle in its small lift class.
Right.
So we're still a small vehicle, but we are the largest in kind of that
small
category.
vehicle class. Right.
Yeah, and we can do this for two reasons. One of them is our engines. So on the screen there, you can see the stage 1 engines are called Reavers. There are 4 of them on stage 1. You could maybe see some TVC wiggles here on the cameras. So there's 4 Reavers on stage 1, and there's 1 Lightning engine on stage 2. Now these are all designed, built, and tested in-house up at Briggs, our manufacturing and test facility.
Right. It's like 30 minutes up the road here.
Yeah, it's like a half hour up the road. And these are all actually tap-off cycle engines, which are kind of a more simple cycle of engine compared to some other stuff you might find out there.
Right.
But that's on purpose. The point of making our engines a tap-off cycle and to target them to be as simple as possible is to target better reliability, manufacturability,
Right.
ease of putting this thing together.
We talked through that yesterday, not trying to push the limits of engineering or physics or anything like that. You just want something that's nice, repeatable, easy to manufacture, lower cost. It's just going to do its job.
Yeah, something that will ideally work every single time.
Excellent.
And then part 2 of why Alpha can be Alpha is my favorite thing to talk about is the carbon fiber composites that make up the structure of Alpha.
Like the main body.
The main body, yeah, like kind of the big skeletal structure of the rocket. So these carbon fiber composites are super strong, they're super lightweight, so you can lift more payload at a lower cost because you're not sacrificing all this extra weight. I think on average for our trade, we're about 30 to 40% lighter using carbon than if we were to use metal.
No kidding.
Yeah.
And on the screen there, you can see some of the new equipment y'all have that are enabling that carbon fiber layup. Can I say that? Is that the right way?
Yeah.
Do I sound cool if I say it that way?
Yes, you do sound cool.
Nice. But that's the AFP, the automated fiber placement machine.
Yes, that is true. So we bought the AFP fairly recently. That's a lot of what I've been doing is helping online that AFP program for structures. AFP stands for Automated Fiber Placement Machine. AFPM, yeah, sorry, cheated a little bit. But yeah, what's cool about Flight 6 for Alpha specifically is that we've started to incorporate AFP structures on the rocket. So our Stage 2 LOX tank, you can actually see it right there.
You can actually see it right there.
Yeah, that kind of white painted cylindrical section, that is our very first AFP flight tank that we have ever made at Firefly. So very exciting stuff.
And actually flying today, like not, we've made a bunch of test tanks and we have a pile of test tanks. That is integrated on the top of the vehicle, ready to go to
It
space.
is right there, yeah. So AFP is awesome. I can nerd out about AFP for a while. It's so cool. And it's really cool to watch too, because I don't think you can really get a sense of scale for it in the videos, but this thing is huge. It takes up the whole building.
No kidding.
Yeah, it's really cool.
It's just like mesmerizing, sort of. You just see the thing and it wraps and it wraps and it just like...
Big rotisserie chicken, just spins the barrel around and it can, go down this big track.
Yeah.
It's really cool. And the arm itself, it's like something that comes straight out of like Tony Stark's workshop. It's
nice.
Awesome.
The whole point there is the automated machine. Sure, you can do it by hand. That's how you originally were making the barrels. But the automated machine is more precise. It can sort of repeat the same things over and over again as you ramp up that production cadence.
Exactly, yeah. So AFP, at least for Alpha, can make production up to 9 times faster and 7 times cheaper.
No kidding.
Yeah, so we're starting to really ramp up into a production cadence. We want our kind of artisan hand lay work to be done on the pieces that need it, and we can take some of the load off of our layup techs and have all the barrels and really big things just get made by AFP.
Right.
Yeah.
Like we mentioned yesterday, the AFP is a large machine that works in
So
certain
the engine
geometries and
chill has
sizes, but there
started
is
there.
still a need for hand layup.
Yes.
Folks actually making the more complicated structures or just geometries that don't work with a big automated machine.
Yeah, very much so.
Nope.
And oh yeah, there you
Look
go.
at that. So the vapors you see coming out the bottom of the engines there are the beginning of engine chill. You'll see those start to beef up. I don't know,
Beef
get
up?
more dense. I don't know.
They'll get more liquidy, I guess.
Liquidy. Liquid up?
Less liquid up. Yeah, they'll be less gaseous and a little bit more kind of like proper liquid.
Yeah, just they look more like they're not dripping. It's like you can see drops almost as opposed to just gas coming out like that.
Yeah, and I can explain that maybe a little bit later. Should I bring out the props?
We should. We have a couple minutes for the props,
Yeah,
I
a couple
think, right?
minutes for the props.
Yeah, let's do the props. Y'all keep watching the rocket here. But
keep an eye.
part of the whole carbon composite structures is testing them, right? You need to make sure that the different layers have adhered together. So we once again have the forbidden ice cream sandwich.
I brought back the ice cream sandwich, the Oreo. So yeah, kind of a quick rundown of how some of our structures work. This is what's called a sandwich laminate, fittingly enough. On the outer edges, the kind of like the cookies of the sandwich, you have a bunch of layers and layers and layers of carbon fiber, and that's your load path. So these two outer sheets carry all the load that the barrel is seeing.
It's like the main structural support, I guess you could say.
Yeah, that's carrying everything. And then in the middle sandwich between the two cookies is the ice cream, foam core. Yeah, so what this does, it's two-part, very important. One, it provides stiffness to the structure because it kind of makes this whole thing act like an I-beam rather than just like a single solitary structure. And also it provides thermal shielding to our propellants. So for something like our cryogenic locks, very important because you've got negative 300 degree Fahrenheit cryogenic fluid inside the tank, and then you've got 70 degree, whatever degree
outdoor ambient fog, I guess, in Vandenberg.
Ambient fog in
marine layer.
So yeah, you want to make sure that you're not just instantly boiling off all of your propellant. So this helps with that.
So it's both structure and insulation in the. I feel like we need to keep reminding people that it is the forbidden ice cream sandwich.
Please don't eat this.
You should not try to eat. That is not a thing. Yeah.
Crunchy, spicy. Your body's not going to like that.
Do not. Yeah.
Please don't. But yeah, and there's every once in a while there comes a point where you have to inspect the health of your structures.
Right.
We do this in a couple ways. I've tapped on this thing before. Tap testing is something that's not just in aerospace industry. You can find it, when you're laying tile.
Right.
Tap test.
So you have a hollow bit under the tile that's going to break one day when you're coming out of the shower or whatever.
If you hear that hollow thud, then there's a void underneath your tile and there's no mortar there.
Right.
Same principle here. If you tap it and you hear a thud, there's a void in your laminate and there's no resin filling.
You don't get the nice clear tap noise. You feel it as well because it's it's piano wire, you said, right?
Yes, this is piano wire on the handle, so not only can you hear if you have some kind of damage, but you can also kind of feel the resonance back through the handle, and you can kind of it's just kind of a second way of...
You hear it's like a tactile thing as well, I guess, right?
Yes, it is.
Nice.
And tap testing, I'm just going to go ahead and send it. So that's what it's supposed to sound like.
Sounds good.
It's supposed to sound super sharp and clear. If you were to kind of hear like a thunk, that's what you don't want to hear.
Right.
This is one of the ways that we NDI our structures. There's another way that we NDI our structures, and that is ultrasonic testing.
Okay.
So not exactly one-to-one, but kind of like a pregnancy ultrasound. You take the goop.
There's goop? There's actual goop?
There is goop. We put goop on the rocket, and you take your ultrasonic probe.
A little wand?
Yeah, you have a wand.
Okay.
And you scan the structure, and what it's doing is it's sending sound waves from your probe into the structure, and it's measuring the time it takes for those sound waves to bounce off something
back.
and come back.
Okay.
So you could detect, if it's going through your structure and, hitting the foam core and
Right.
coming back, that's a different time than if it would go through your structure, hit a void or disk bond of air, and come back.
Okay. So you're sitting there, you have the goop, you have the wand, you're like scanning it, and you're like, congratulations, it's an alpha.
We're just
an alpha.
listening to them,
Parallax
their
rocket.
commentary because
All right, we are under 12
They
minutes now,
explain
actually 10 and a half because we like talking about structures.
many
One day we're going to have
details.
to bring some other structure testing stuff in here. People are going to be like, oh man, it's the tap thing again.
Yeah.
But let's talk really quickly about what is going to happen because things are going to start happening fast.
Sure. So right now, so we're under the last 12 minutes of launch. So we've been doing a bunch of commands and health checks,
Right.
300, including we've been chilling in our stage 1 engines. So kind of we talked about like that kind of gaseous thing you see on screen.
On screen right there.
Slowly getting more and more liquidy. That's us pulling cryo fluid through our LOX pumps.
Right.
Cool them down to the temperatures that we need them to operate at for flight.
So that's just, you don't want to surprise the temperature. You want it to be a nice thermal gradient, I guess. You sort of bring them down over time to their operating temperature as opposed to suddenly going from normal temperature to cryo temperature.
Yeah, if you pull in that 300-degree, cryogenic fluid onto a 70-degree pump,
Yep.
you're going to flash the gas. It's going to lead to cavitation and all that kind of grossness. So we want to stay away from that. So we've been doing that since T-minus about 15 minutes.
Right.
They need some time to kind of chill in. We've also done some ground side prep. So TVC wiggles. TTEB, spin start verification, fuel
Right.
pre-press, stage 2 TVC wiggles. There's just a whole line of things that we work through.
We've got all sorts of acronyms we're going through here, but at less than
Yes.
10 minutes to launch, we better keep pressing ahead. Fuel pre-press is a thing that is
Yes.
going to start happening in about a minute, and we'll get some more TVC, the thrust vector control wiggles, just making sure everything is moving the way it should move. At some point, we'll transition to internal power
Yes.
as well,
Yeah.
sort of unplugging the rocket from the ground, making sure that it's all healthy on its internal power, I guess not generation, batteries really,
Yeah.
so that it's ready to go. And then we're going to see some larger things on screen, right?
Yes.
Like right there.
Yeah, so you'll start to see that strong back pull back. Well, first the collar arms will open.
Right.
The strong back doesn't pull back when the collar arms are closed.
Those are on the top. Oh, it's like right over here on the,
Yes.
the side.
Yes, so you can see them in that shot. Kind of those little cylindrical looking things that are
The claw pinchers.
holding, the crab pinchers that
Yeah.
are holding on to that stage 2 LOX tank. Those will kind of separate and get wide, and then the whole tail will kind of pull back.
Out of the
Alright. Just hearing from them there. Getting back to my commentary here, at least. So we're coming up to 8 minutes until the launch. These are now important steps for mission control. They will execute the final preparations before the liftoff. So yeah, that's very important. And let's actually take if they're gonna show. Here we go. So here we have the board, what will happen in today's launch. So you can see Mach 1, Max Q, MECO, stage separation, stage 2 ignition, fairing jettison, deco, and payload deployment. Payload deployment actually happens pretty early on. Surprising that it is going to happen early on. As we saw on the Vega C launch earlier today, it happened around 50 to 52 minutes after the launch. So surprising to see that it is now earlier than others, but that might be me. So yeah, that's pretty much what is going on. So you can see the commentators on your screen. Let's actually take a look how it looks like here. You can see the fog layer. That is not the ocean, that is the fog layer surrounding the launch site. That's how far away this camera is. If we get the camera that's closer, Dangermon 2, which is the closest camera to this launch site, you won't see anything because it is very foggy there. So I think this is the best we get, hopefully, because I don't know even if we're even gonna see the launch. Probably because of the fog we will. But yeah, we'll see how that goes. So we got about 6 minutes, 10 seconds into the launch. So next step on the countdown is going to be strong back retract, which will happen in about 30 seconds or 20 seconds. I'm not sure, but we will see that happen though. Strong back retract in about 10 seconds. We'll wait until we get footage of that strong back. There we go, strong back retract should have started now. So it's now clearing away before the launch. There we have it. Strong back retract has started. Just less than 5 minutes away from the launch. So yeah, about the connection for the launch. So about 10 to 20 minutes after the launch, we will lose connection to the launch vehicle, so we won't get telemetry for payload deployment here. So I assume they are going to end their broadcast early on. But it is going to be interesting to see the liftoff happen in 4 minutes. Just want to mention that quickly here. So yeah, we got about 4 minutes until the launch here of the Lockheed Martin with the of the Firefly Alpha rocket with a message in a booster. My voice is all used up for Vegas-y, I think. So excuse me if I sound weird. But yeah, we're 3 minutes away. Three and a half minutes until launch. The final go no go pull will start shortly.
But
Let's actually
we
listen to
do
the
see
commentary.
the rocket silhouetted on the pad. You can see the strong back has retracted a little bit, and we're going to come in to listen.
Chief Engineer, send it
to the final command.
Launch Director.
Launch directors go.
Rock.
Rock, range green.
We are go for launch.
Wow. We are go for launch. Good sign. Alright, we're getting closer to the launch here. Two minutes. What? Less than 2 minutes away. Right. Okay, we're getting better sound from the launch pad now. 1 minute and 15 seconds. We're gonna closely listen in to the countdown net as we're getting ready for that launch. It's very foggy, so let's hope for the best. Less than a minute away.
Helium bubbler.
Seconds. 30 seconds.
Auto arms off. Vehicles in autonomous mode.
20 seconds. Here we go.
Nominal stage 1 TVC motion.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Liftoff with Firefly's Alpha rocket with message in the booster.
Flight operator, transition to ascent ops, ground operators, please. Position to ground, channel for taxi.
T plus 20 seconds. T plus 30 seconds. Beautiful launch from Vandenberg Space Force Base. No views from here, so I think we're not going to get any shots there. Coming up Mach 1, now past Mach 1.
Vehicle supersonic.
Supersonic already, insane. Coming up Max Q, look at that.
Max Q.
Beautiful shot from the Alpha rocket. Now 1.5 minutes into flight. Looking good. Coming up to 2 minutes.
And you can see the atmosphere thinning.
You really can. That plume expansion there.
That's beautiful.
Plus 2 minutes.
Should be coming up on Miko here.
T plus 2
in about
minutes.
30 seconds.
God, the way that comes back together, it's literally the exhaust gases bouncing off the atmospheric pressure and then coming back together.
Beautiful shot.
Continuing to
from the
go
ground.
down range here.
From the ground, look at that. 2.5 minutes into liftoff. Coming up
2.5
to
minutes
Miko.
after liftoff.
Exactly.
Coming up on
Stage separation.
Miko.
Stage 2 ignition. Chamber pressure looks nominal.
Oh. Oh. It's moving in all directions. Oh crap. We got fairing separation.
Have a view from the vehicle here.
You can see the fairings jettisoned.
Yep.
Otherwise, you couldn't see the Earth.
The limb of the Earth in the background. Little bit of motion there.
I was concerned for a little bit. Looks good now.
But now we're into that longer second stage burn. The lightning doing its job to get that horizontal velocity going around the Earth.
That was a harsh separation.
And there is
I
that
believe.
aft-facing view in the background there where the rocket just took off from. Here you can see the booster is no longer behind the rocket. I don't think we can see it in this shot. I suddenly wonder if that little dot up there is it. But this is the second stage, looking backwards at the engine on the second stage.
Camera operator cannot hold the camera stable.
Looks like some of the trackers are having a little difficulty keeping it in frame there.
The booster might have exploded. Because I saw something pop.
It's really interesting how clear the exhaust is here. But once again, going to stay with it. We are going to come up on an expected comms blackout. We're going to try to share with you the views here from the vehicle as long as we have them. The comms blackout is expected, but it's also a little estimated. So if the feed cuts out a few seconds before the exact timing that we were talking through, that might be nominal.
Yeah.
How you doing, Morgan?
I'm doing great. Sorry, I'm being handed things. And I can only focus on one thing at a time. Yeah, I'm doing great. That was a beautiful launch. And I just love watching these camera views.
Yeah, it was a little tough there with the marine layer. We had a lot of bloom on the ground. A little tough to see the rocket lifting off. I love that we kicked it off with the engine shot. Just kept it with the engine shot as they sort of exited that blast camera down in the trench itself, or I guess right under the engines. But Lightning and Stage 2 continuing on with the propulsion here.
Yeah, again, we're expecting to burn this engine until T plus 8 minutes and 28 seconds.
Right.
That's when we expect SECO.
So another 2.5 minutes roughly in this burn.
Yeah.
Yeah. And again here, this phase of flight is all about gaining velocity around the planet, right? The first stage got us up out of the atmosphere. It got us sort of away from the ground a little bit. And here we're basically flying sideways. See this question a lot, like, oh, why did the rocket turn sideways? And then look like, from my perspective, it was going back down to the water. Well, the Earth is round. It was going around the Earth, over the horizon. That's exactly what the Lightning engine is doing here, pushing that stage. And the payload, I like this. Look, we got both cameras.
Oh, nice.
On around the planet.
Yeah, orbit is basically just falling constantly and just missing.
Missing, yeah. Coming up on T plus 7 minutes. We're also listening into Mission Control now, so if any call-outs come from Mission Control, you will get them directly from there.
Beautiful shot from the payload cam, at least from what I'm seeing here. We have two shots on their stream. I'm using a cutout so you can see only one, so it looks better. Take a look at the stage again.
That really is just a cool shot. Like you can even see, like, it's headed south, and the sun was rising. To like if you were on the rocket, the west would have been the left-hand side of the rocket, and there you can see the Earth a little bit illuminated there, and then a little bit darker on the right-hand side.
You can see the sun reflecting off of the rocket itself.
Yep. But about 7.5 minutes, and coming up in just about a minute, we're expecting that SECO, second engine cutoff. Again, we may not have views all the way up to that. We will see. We're going to share the views with you as long as we have them. But let's see here in about another 30 seconds whether we get those views the entire time. And then remember, the payload deploy is not expected to be seen live here. The payload deploy isn't happening until a while after SECO.
Yes, so SECO happens again at about 8.5 minutes, coming up here in a couple seconds, and then we'll see our planned comms blackout a little after 9 minutes. Payload deploy will happen somewhere around, I think, 12.
Right. I'm watching the flicker of the second stage engine there.
Assessing.
and had the Seco call out from
seeing
mission
Seco.
control, and you could also see the engine shut down.
Oh, well.
Expected LOS at VTRS in 60 seconds.
And rapidly approaching that expected LOS like we talked about before liftoff. Back in mission control, you can see everyone focused on their consoles. I think the call out was assessing data.
Oh yeah. When I run tests and things, I wish I have more than 3 monitors. I usually see a bunch of flack for people having 3 monitors in the control room, but you're actually looking at a lot of data at once.
Right.
You've got the GUI on one, you've got all your plots on another, you've got cameras on another, and then sometimes I want a fourth for another another monitor full of data, because there's just so much to look at one time.
Right. Now coming up on T plus 10 minutes. We're going to have some replays for you coming up here of the liftoff cameras we didn't show live. And also we'll talk how you can keep up to date with the mission status here. So now's the time when we can ask, if you were out at home, did you step outside during liftoff, and were you able to see that? If you're over there in LA or San Diego, over in Phoenix, Arizona maybe, all the way over to Albuquerque, let us know in the chat, did you catch any information, did you catch any shots of that launch? And I think we just heard the LOS there. And tag us on social media if you did.
Okay. Fair with that.
All right. So folks, that is the views that we are able to share, that we have, because we're now in that comms blackout. And as we discussed earlier, because of the long delay before we're expected to get that signal back, then the priority order of downloading the data, getting the telemetry first, and then getting any video that's able to come down of payload deploy, that's not going to happen for almost another hour and 20 minutes. So we will not plan to stay live through that. But as a quick reminder, you can keep up with what the mission status is by following along on social media. Best place might be the Firefly main website, where you can find all the social media accounts, but expect updates as to the mission status after we get the folks here in mission control assessing the data that came down before that, and then getting any data that comes down after the comms blackout ends in another 25 minutes or so. We're going to stand by for just a few more minutes to see if we have any updates for you.
Alright, so at this point, looks like a successful mission.
All right. The big thing here is the data coming down, the team's reviewing the data that came down on the rocket. And I think our best possibility here is to start wrapping up and have y'all give you the good information on how to find on social media and on Firefly's website.
Alright, so there's gonna conclude the coverage here. So yeah, what a launch we saw today of the Firefly's Alpha rocket with the message to the booster. With LM400 on board, demo satellites on board. Satellite, actually, it's one big thing, one big payload. So yeah, that will conclude my coverage here. I want to thank everyone for watching today's live stream, and yeah, that will conclude it for me. We will be back, I think, when are we back? Actually, I'm not sure when we will be back. I'll just check. Let me see. We'll be back in 2 days, May 1st, for the Starlink Group 15-3. We won't have commentary for that, so it's just going to be a no commentary stream with mission control and audio only stuff. So that will be doing it for me. Thank you so much for watching, everyone, and we will be back on May 1st for Starlink Group 15-3 launched by the Falcon 9. See you then.